Like Elijah said, my name is Aleatha Singleton, and I'm an immersive tech UX design professional with over 22 years of experience designing for kiosks, websites, mobile apps, desktop software, and extended reality for many well-known and not so well-known companies. But today, I'm not speaking on behalf of or representing a company. Today, I'm talking to you as one professional UX designer to another. I'll talk about shifting your mindsets from designing for traditional 2D displays to start thinking in three-dimensional immersive design. I'll go over the differences in the types of digital realities within the XR spectrum, and then I'll give you a basic overview of some of the UX best practices for this space. So let's get started. Everything we already do for web, mobile, and desktop UX design is still relevant when designing immersive experiences. The process still includes discovery, ideation, prototyping, testing, building, and iteration. Although the goal is basically the same, which is to design delightful and compelling experiences that are easy to use, the platform's completely different. Instead of designing for 2D screens with a limited screen size, we're designing for another dimension in which 3D spaces and the world around us are the canvas. This means we have to shift our mindset to start thinking in 360-degree, three-dimensional spaces. Unlike with 2D experiences where you can control what the user sees when, with 3D experiences, you have to take into account that the user may look anywhere at any time. This is where designing for print or for real space, such as installations and exhibits, are very relevant skills for creating virtual spatial designs and experiences. It's also important to understand movement in virtual space. Real-world objects can move in 6 different ways in physical space by rotating and moving back and forth and side to side on X, Y, and Z planes. In virtual space, there are 2 types of freedom of movement available depending on the technology being used. And it's important to know which technology and platforms you'll be using before you start designing and developing the experience so that you don't have to go back later and make costly changes. 3DOF, or 3 degrees of freedom, is mainly seen in phone-based headsets such as Google Cardboard VR and the Oculus Go headsets. It allows you to look around with your head, but you can't move around as you would in the real world. If you tried to physically move your body in real space, the virtual world would follow you on a gimbal instead of you moving in that virtual world. If you want to allow users to move around in this type of world, you would need virtual locomotion, which causes more of a risk of motion sickness. There are methods and workarounds to reduce sickness, which I'll briefly cover in this talk, but you can find out more about it on the Medium blog. 6DOF, or 6 degrees of freedom, is the type of movement you see in the higher end devices, such as the HTC Vive, Oculus Rift S, Valve Index, and the more affordable standalone Oculus Quest. You can rotate and move around in virtual space the same as you would in the real world. You can walk around, peek under objects, and interact with them as long as the experience has been created to do so. For larger world maps or limited physical space, you would have a combination of virtual locomotion and natural movement. The virtual locomotion still poses a risk for motion sickness when the real physical speed of movement doesn't match the virtual speed. Again, there are workarounds to reduce sickness, which are covered in the Medium blog. And as with any other traditional technology, different UX rules apply for each of the different types of digital realities available. So it's important to be able to distinguish the differences so that you can make better decisions on which to use for any particular project. For example, training simulations could be created in augmented, mixed, or virtual reality. If in augmented or mixed reality, the user can walk around freely, and in that case, you would want to provide information that adds insight while ensuring that the user's vision of the real world isn't hindered by the interface. Whereas with virtual reality, the user's confined to a limited amount of play space where locomotion is handled in other ways. So to help you make more informed decisions, I'll give you a quick rundown of these different types of realities. Back in 1994, a group including Paul Milgram and Fumio Kishino created the reality-virtuality continuum in order to roughly illustrate the extension of reality from completely real to completely unreal. This is simplified illustration that doesn't get into all the nuances of the space, but it is a good start to help you understand the major differences between the different types of reality. And this complete spectrum of realities has been coined extended reality, or XR. The X can also be used as a variable for whatever comes next. And I'll break all of these down, starting with the real environment, or as the Hockey Hall of Fame refers to it, real reality. This is the real physical environment that you're used to experiencing, but we are now interesting, or maybe sadly, going to have to start distinguishing from the other types of reality. And then augmented reality, or AR, overlays information onto the real physical world. There are many use cases and examples for augmented reality, but one example would be this wayfinding app where you're overlaying the subway line directions and information onto the real world based on your physical location. Mobile AR won't be in this talk or on my Medium blog, since the interactions are still performed on a mobile device's 2D screen. And it would be best to refer to the HMI guidelines for those devices if you would like to learn more about them. There are a few products on the market that can easily be confused with augmented reality, but are more accurately fall into the category of smart glasses. And these smart glasses allow you to pull up information onto a small 2D screen within a head-mounted display as reference, thus occluding the world instead of augmenting it. And while they still have very useful applications, they don't overlay digital information onto the real world in 3D space. So they don't truly fall into the augmented reality spectrum, even though marketers and even some companies may place them there. The Tilt 5 AR glasses are true AR glasses that target the tabletop gaming fan base, since they can add more drama to your traditional sessions with special effects and 3D world maps. And you can also play remotely with friends as long as they have a pair of glasses. And they've been delayed by COVID, but have successfully completed their Kickstarter campaign and are now in production, and pre-orders are being taken. On this reality virtuality diagram, there are various levels of augmentation, which range from traditional information overlays of augmented reality to environments that intermix the real world with life-size digital objects. And this range of augmentation is known as mixed reality, or MR. Mixed reality can increase visualization and collaboration with people in the room or with people around the world. An example of this is the Spatial app, which is in early phases and can be tried for free on VR headsets and on the HoloLens. And as you move further across the mixed reality gradient, the levels of real physical environment versus the digital environment begin to shift and switch to become more of an augmented virtuality, where your digital reality is then being augmented with the real world. An example of this would be the leap motion, which uses objects in the real world, such as your hands, and creates virtual representations of them so that you can use natural gestures in world. Oculus has also released the beta version of their hand tracking technology on the Quest, which works similarly to leap motion. However, instead of having to attach an external device, the Quest uses existing inside-out tracking. They've released their design guidelines, which you can check out on their developer portal. Currently, there aren't very many examples of augmented reality, virtuality available, but as the technology advances, you'll start to see more arise, or at least to me, in my opinion, it seems that it's trending towards being included in the VR category as an extra level of immersion instead of being its own category. And finally, virtual reality fully transports and immerses you into a completely digital world. A great example of this is Unreal Engine's VR mode, which allows you to design for VR in VR and makes you feel like you're actually there. You can walk around and interact with the characters and the objects in that world. Increasing levels of immersion into these virtual worlds is made possible through the creative use of haptic devices carefully placed in the environment and physical props. Those levels of immersion are only going to keep getting more realistic as time goes by. We don't have time to go through all of the UX best practices I've written so far, but I do want to give you a quick overview of some of the foundational things to keep in mind. Studies show that if a user has a bad experience with a new technology, they're more likely to consider all experiences within that category to be a bad experience and are less likely to adopt it or give it another chance in the future, even when those subsequent experiences are higher quality. That's why I say that it's imperative to the longer term success of new technology that the user experience be well thought out and well executed. Motion sickness is one of the most common negative side effects of VR experiences, and this can include a feeling of seasickness, headaches, general nausea, dizziness, vertigo, or even in some cases vomiting. This happens when there's a mismatch between what's being seen and what's being felt, or in other words, your eyes see that you're moving, but your body doesn't feel any motion. Many people in the VR dev community laugh at this and don't think it's a big deal, especially if they're one of the fortunate ones that don't get motion sickness. However, it's very important to take it very seriously and ensure that the experiences we create have precautions in place to reduce the possibility or the risk of sickness. I've seen way too many examples of people trying a VR experience, getting sick, and never wanting to put a headset back on again. And personally, I've gotten sick from VR experiences that ruined my entire evening, and now I refuse to ever play those games again. And every time I think about one of them, the first thing I remember is feeling sick, and I warn my friends to stay away from even buying those games, and that's the last thing that you want. So if you want a better return on investment for your experiences, take motion sickness seriously. Explore ways to cause objects to move while keeping the horizon steady and the user grounded. If you don't have a grounded point of reference, the reaction's similar to how people are more likely to get seasick when they're further out to sea and can't see land. If you get a little better when you go out on deck and stare out at the stable horizon, but not as much as when there's land in sight. If a very large virtual object is moving, the user can get disoriented and think they're moving, much like a car sitting at a railroad crossing. After a certain amount of time, the driver feels like they're moving sideways instead of the train. You can avoid this by placing smaller fixed objects within the space, like the railroad crossing signs and arms and the foundation supporting them. Let the user initiate the control of movement. Start with slow and smooth motion and gradually increase the speed steadily. This is similar to how a driver has less chance of becoming car sick than a passenger, since the driver is able to anticipate what's about to happen. It's also very important that the experience maintain head tracking, especially for VR. Even a short pause of head tracking can cause illness, much like what you would get with vertigo when the environment freezes, even though you're moving your head. Test the application closely for unintentional latency or freezes in performance. With the human eye, your lens shapes itself to focus on different objects while the rest of the world blurs. And this helps your eyes focus on the targeted object while reducing eye strain. As you get older, the lens hardens and makes it more difficult to quickly focus on objects that are too near or too far. When this happens, if something's too close to read, it's going to hurt your eyes. That's why, as you see people age, they have to start holding things out further to read them comfortably. The current lenses in XR headsets are fixed focus, kind of like the aged eye. Only instead of taking a longer amount of time to shift focus, it's unable to shift the focus at all. This causes eye strain as our actual eyes are working harder to try to shift focus on objects in digital space. One of the first things that people say when I mention needing glasses to see in a headset is that I could just wear contacts. People who wear contact lenses should be fine, and that would be an ideal solution. However, keep in mind that not everyone's able to wear contact lenses for various reasons. Custom prescription lenses are available, but they're costly for the individual and impractical for shared devices. Remember that those of us who need these prescription lenses also have to pay for our everyday glasses. Depending on the medical condition, many people need prescriptions updated more frequently than once a year. It's not sustainable to have to buy new prescription lenses for each XR headset in addition to everyday glasses each time the prescription changes. Tech companies such as Serial are working on ways to simulate real-world depth of field in real time by tracking your eyes and digitally focusing on that area or that object, much like the human eye would naturally behave. This will reduce the risk of eye strain, and the digital vision correction it offers will also increase the scalability and affordability of XR eyewear, since it would reduce the need for custom prescription lenses in the headset. The technology is still in the works and it's not currently on the market. If you've ever gone to the eye doctor and you've looked in the little machine and focused on the little hot air balloon, then that is an example of the digital vision correction. So what do we do in the meantime? I would recommend that you evaluate the hardware to ensure a person can wear their own eyeglasses comfortably within the headset. And also ensure the hardware doesn't cause a risk of damage to the eyeglasses while putting on or taking off the headset. And watch closely for signs of eye strain or headaches within your user group. They'll often say it's fine when they're actually just trying not to inconvenience others. In order to avoid eye strain and headaches, it's important to pay close attention to the placement of the text elements in virtual 3D space. Font size, depth, contrast, spacing, density, lighting, and many other things can affect the legibility of text and UI elements. Try to keep the text at an optimal viewing distance of 2 to 3 meters from the user. 1.2 meters is the minimum recommended distance for text content, but that could still cause eye strain. You'll also want to keep blocks of text short and simple and follow real-world poster and signage examples when determining text sizes, weights, and spacing. When creating UI elements and interfaces within a virtual environment, real-world physical ergonomics should be taken into consideration. Be sure to keep head rotations within comfortable ranges, especially when using gaze targeting or for longer durations or more repetitive tasks. Assuming a person is sitting or standing still and focusing on something, the most important elements should stay within a 20-degree head tilt up and a 12-degree head tilt down vertical space. The main elements that you're wanting to be within the user's field of view with a comfortable head turn should be within a 154-degree horizontal space. An easy way to measure this is to hold your arms out straight and place your hands where they're still visible within your periphery. And the maximum required head turn should be kept at or below 204 degrees horizontal, or where your arms are stretched out as far behind you as they can be to the sides, assuming you have normal physical range of motion. Spending time in a virtual environment can be physically and mentally tiring for people who aren't used to it. Be sure to consider the length of time the user will spend in the headset for your application and design the environment and the interactions with the physical ergonomics in mind. When designing vertical interfaces, it's best to keep the user from having to keep their arms raised for long periods of time. Otherwise, their arms will become fatigued and will start to hurt. The longer they keep their arms in the air, the heavier they become. In the tech world, this is known as gorilla arm. As hand tracking becomes more prevalent in the XR space, it will be all the more important to keep this in mind when designing interfaces. Minority Report is almost 20 years old, but if someone references the pre-crime scrubber, chances are you know exactly what they're talking about. During filming, Tom Cruise was using the prototype of an actual technology created at MIT. At the time, rumors abounded that he had to take frequent breaks on set while filming the scenes with the pre-crime scrubber. Although he was in great shape, his arms were getting tired from holding them up for so long when interacting with the vertical gestural interface. Sorry, my voice is going out. So give people the ability to stop at any time. Besides fatigue, life happens, and people need to stop for any number of reasons. Give them an easy way to do so. Give them an easy and a clear way to exit, and give them the option to start back up where they left off. And remember that it's important not to blindly follow cool interactions found in sci-fi films. You need to know what's good and what's bad about them, and whether they're a good solution to the problem you're trying to solve. And there is so much more that I could cover, but I don't have time to go through it all today. I've created a list of links to reference the information I've mentioned today, and that will be available in the booth if you want to go check it out. And you can read all about the best practices I've published so far on my Medium blog. Articles are added regularly, and I have them categorized and broken down for quick reference by topic. Each article includes a TLDR list of do's and don'ts and links to resources to learn even more. And also be sure to follow me on LinkedIn, Patreon, and Twitter so you can stay up to date on the more in-depth content and resources I'll be adding in the future. And that's all I have for today. And I'll turn it back over to Elijah for Q&A.
All right. Thank you very much, Aleatha. That was wonderful. Really great presentation. I loved your visuals. I loved your information as always. Looks like we don't have questions. So if anything, I could probably ask you some questions if you want to keep going just a little bit longer. Then we'll end it early. So a couple things that I saw were really interesting, but one thing I want to highlight first is that you seem to I don't think you really mentioned that here, but you have a whole, part of yourself where you look at sci-fi interfaces. So can you tell us more about like what do you do in that regard when you're looking at these sci-fi interfaces, and what stand out as really good ones and what are bad ones?
So I don't do it as often as I used to, but I would sit for hours and look at a film. It's like you couldn't watch a sci-fi film with me because I will pause it and rewind and stand in front of the screen and stare at the interface.
Right.
But what I do is I derive interaction design lessons from those, good and bad, and I take those learnings. And there is this blog called sci-fi-interfaces.com written by Chris Nossel and Nathan Shedroff that I'm a guest author for. And you derive the interaction design lessons, and you take those learnings because you can take their bad ideas and turn them into good ideas. You can learn what not to do. If you pay attention to sci-fi, there are tons of very deep ethical concepts within them. And you can learn from that. You can learn, well, actually, this is not such a good idea. We should be more responsible about how we create our technology. Just because we can do it doesn't always mean that we should. And so you can take those learnings. It's a combination of the interactions and ethics is what I look at, and then blog about it. I'm behind on my blogging on sci-fi because I've been doing the virtual reality and XR stuff, but
Yeah, definitely. And I don't think you put that out there, but where can we find more about that site, that information as well?
it's on the same Medium blog as the best practices. It's called Future Tech.
Okay,
There's a tab
awesome.
called Future Tech, and it'll give my list of articles, and then it'll link to sci-fi-interfaces.com as well.
Awesome, thank you very much. Shannon in the chat said she doesn't deal with AR and VR, but never thought about people with glasses, even though they do have glasses. So great point, insights on that.
I have tried to use the HoloLens and the Magic Leap, and I can't because the two will work with your glasses, the HoloLens too, but the original one had the little nose piece that my nose is too small, so I can't fit both glasses and HoloLens on my nose. So I couldn't use them because I couldn't see the interface at all.
Because
I had to take my glasses off.
Yeah, I've had to experience that a lot when I was working at the arcade. We were using mostly the original HTC Vive, and there were so many people with different kinds of glasses. So you had to kind of balance the weight of the headset pushing against the glasses, or if the glasses were too wide, if like the frames were too wide to fit inside the lens. So it's just really surprising because the amount of people that wear glasses is very high. So if your headsets
and
can't
I'm sure some of the
them,
people making them wear glasses. Like,
exactly. Exactly. Yeah. So you have to wonder, like, I don't know if you have any insights on this, but what do you think are some of the cost considerations, or the, I'm not sure if it's accessibility per se, probably is as well, but what are some of the trade-offs that make people to develop these headsets without considering things like glasses or other considerations like that?
I'm really not sure. I think at first, when people are trying to get something out the door and innovate, they're trying to take the path of least resistance, probably.
Right.
But Oculus, if nothing else, has added it comes with a little spacer so you can add an extra distance between the lenses and your face to give you more room for your glasses. So that is something that other headsets could easily do, even if they don't make it in its natural form that way. There could be some kind of add-on spacer that you could add for your glasses to, because the HTC Vive for sure pushes on my glasses and it's too close. But some of the other headsets like the Sony, which you see back there, maybe it gives plenty of space, and it actually lets you pull the headset out and push it back in so you can position it over your glasses, which is very nice. The trade-off is that you're going to get less of you're going to see more of the world in the cracks.
Right.
Because they're further away. So if there's a way to block off that, then that will help.
Right. Okay. All right. We're getting a few more questions in here. We have one for Shannon about glasses, and then another one I missed from Aleatha about the sci-fi setting. So I'll go back to that one, Aleatha, and I'll start with this, since we're already on the glasses topic. Shannon says, do you think the solutions for the glasses wear headsets that fit everyone, or the screen adjusted to different vision settings? So should we have, headsets that are adjustable, or that, are kind of like multi-fit? I forgot the term for that. Or should you be able to, change those settings through software or something like that?
It might need to be both, because you can't do a one size fits all, even for your eyeglasses. I am borderline child's eyeglasses. And these are big. These are actually a little big on me. I think they're preteen.
Right.
So you're gonna have to have, I think, a combination. And Apple for sure is working on patents, and Serial, like I mentioned before, is working on trying to do digital correction. And this is something that I think the eyeglass industry is also trying to do, so that you don't have to keep buying these things. You can just digitally correct it with software. It's not ready, obviously, but they're trying to do that. They're trying to get that ready, because now you're able to go into an eye doctor, depending on the eye doctor, of course. They have those machines that you can sit in front of, and you can stare at the little hot air balloon, and it'll digitally figure out your prescription for them. And then they just go in and test it and make sure it's right.
That's so interesting. Yeah.
So it's there, but it's not here.
Right. All right. And Radhika's question says, first, thank you for the presentation. And question says, related to some concepts in sci-fi movies or series like Black Mirror, do you see any of them actually happening anytime soon? And if yes, which ones?
Well, sci-fi has been inspiration for innovation for a long time. If you looked at Star Trek, the people who made the first Motorola cell phone, Star Tech, were big fans of Star Trek. And it even looks like the communicator that was in Star Trek. It flips and everything, just like the communicator in the original Star Trek. So sci-fi has actually been inspiration for it for a long time. The tablets that we use now, the iPad, those were from sci-fi. So it's already been happening for years. And things that we think are sci-fi now, that's one of the reasons I look at ethics, is because it is such a big inspiration for people creating technology, that you really need to stop and think about whether or not it should be done. Just because you can doesn't mean you should. Like they're working on trying to put dinosaur DNA in and recreate dinosaurs. It's like, did you not watch that movie?
Yeah. Nothing can go wrong there.
Oh. So yeah, it's happening now.
Right. Yeah, definitely. And in that regard, like the idea of holodecks, I think that's a very popular one. And you see that where people are trying to, it's more of a marketing ploy right now, calling it a holodeck. Really is just a, virtual reality environment. But I do see that as interesting, that we get so much inspiration from there. But something I noted is that for a lot of these sci-fi interfaces, especially nowadays, we're realizing that the laws of physics is like a hard limit on what you can actually do. Like the using holograms, for instance, is very, very difficult because all of that seems to bend those laws of physics. And then same thing with holodecks and teleportation, things like that.
So there is this thing that they're working on called volumetric projections, which creates little digital objects in the world without the use of a screen. And it's using these lasers that shoot light and create plasma at an incredibly fast speed of rate to create something that floats in space that you can touch. And so they're working on it, and they've got a very small little interfaces that you can interact with, and I think it's Japan's also working on a floating, thanks to COVID, they're taking it further and they're trying to get there faster, working on floating displays that you don't touch. And so they're working on kiosks right now for that. So they're working on it right now, and I can see it's possible. I don't know how fast, because depending on the technology, the one I was looking at with the lasers that's a laser. So you got to get the speed right, or you're going to burn someone.
Yeah.
So, yeah, it's a little bit ways off.
Definitely.
But it is possible. Things that we think are impossible now are gonna be possible in the future.
That's what's so exciting about being alive nowadays. But as always, thank you so very much. If anybody has any other questions, feel free to ask them now. If not, we'll go ahead and end it, so you can have a break before the next session, which is with Jordan. Just so everybody knows, we do have a Q&A panel with all the speakers. Well, most of the speakers who can make it at the end of my talk. So feel free to attend for that as well if you want to hear from Aleatha again. She does have a booth set up in the AirMeet area. So if you want to see more information from her, you can go there. And I think that is it. Yeah. Anything else you want to say?
That was it. Thank you for everyone who made it. I appreciate it. Thank you for your questions. And feel free to reach out to me, really. I don't mind.
So. All right. She really doesn't. She's incredible. So thank y'all so much. And see y'all later. See ya, Aleatha.
Thank you. Have a good day.
All right.